Ever since I was a child, I have dreamed of automation. I find the concept incredibly appealing because it aligns closely with one of my core beliefs. Address the root cause, not just the symptoms. When done right, a solution can be implemented once and with minimal maintenance continue to function effectively forever. In this series, we will be building an automated fulfillment machine from the ground up using 3D printing, lasers and more, but mostly 3D printing. The basic idea is that we have the scenes and we have a box, and I need some way to automatically get the scenes into the box. The first thing I need is some way to dispense the scenes. Basically, I need to have the scenes in a stack and dispense them one by one. Then there are a lot of steps in between that and the box, but today we're going to be focusing on the dispenser. My first idea was to have the scenes stacked on top of each other, and then have a pusher which moves back and forth to dispense the lowest scene. The stack will then move down due to gravity, and allow the motion to happen again. This was my first idea, and I didn't see any immediate issues with it, although there are probably better ways. Anyhow, I decided to start designing some parts. This is my first pusher design. It features a stepper motor on one end and a holder with a bearing on the other. These are connected by a lead screw and two aluminium rods. In the middle is the pusher, which connects to both the lead screw and the rods. This setup converts the stepper motor's rotational motion into linear motion for the pusher. One potential issue is the friction between the plastic pusher and aluminium rods, but I'll address that later. For now, I need to see if the mechanism works in practice. For the steppers, I chose two trees NEMA 17. To control them, I'm using a Wemos D1R32, which is an ESP32 in an Arduino Uno form factor. I also added an Arduino CNC shield that fits perfectly on top of the ESP32, allowing me to use the A4988 stepper motor drivers. This setup is great because it minimizes cable management. The only cables needed are for the power supply and the stepper motors themselves, which connect directly to the CNC shield. Plus, it's cost effective. These components are affordable and readily available from China. After some 3D printing, coding of the ESP32 and a trip to the hardware store, along with having to endure my Ender 3s for the last time, I ended up with prototype 1. Everything moves smoothly and it appears to work well overall. It's a bit noisy, but that can be improved with higher quality stepper motor drivers. The main challenge right now is the homing process. I have to manually move the pusher to the front position and set the home position there. Currently, the pusher doesn't know its actual location, so if it encounters any obstacles during travel, the homing will be incorrect, leading to errors in the subsequent movements. I'm exploring ways for the pusher to determine its real location. One idea is to implement a homing switch, like those used in 3D printers, such as the Ender 3. This would allow the pusher to automatically home itself when it hits the switch, eliminating the need for manual setup. I'm also considering various sensor options, which would entirely eliminate the need for homing, but I haven't decided on the best sensor for this yet. Despite these issues, I want to test it further, so I need something for the pusher to actually push. For that, I designed a simple holder that functions essentially as a shelf, specifically designed to fit over the pusher mechanism. This holder features two compartments per pusher for the scenes, which also uses metal rods to scale each compartment vertically. This setup allows the pushers to dispense two scenes at a time in a single motion, with the potential to expand by adding more compartments along each pusher. However, one challenge arises. If we increase the number of compartments, the pusher will need to be longer. This is an issue since a lot of space will then be needed for the pusher to retract at the back. The current design relies on the scenes not being pushed to rest on the pusher itself. This leads to concerns about the weight on the pusher, which could pose a problem if there is too much weight on it. Anyway, I've decided to print it to complete the first prototype of the full dispenser. Here's what a fully assembled dispenser looks like. I've tested it extensively and it performs quite well overall. Most movements work smoothly, but there's one issue to address, as mentioned previously. The pusher can occasionally get misaligned, especially if the scenes at the end start stacking up. This shouldn't be a problem in the final version, where those scenes will be taken care of by the conveyor belt. Still, it's wise to consider a solution, as you never know when something might obstruct the pusher. Another minor issue is that the compartment for the metal rods isn't tight enough, allowing some movement of the sins. This hasn't caused major problems yet, provided there are at least 2 sins in one compartment. However, if only one remains, it could get stuck when it's time to dispense. The biggest challenge right now is the construction itself. The design lacks rigidity, and I had to cut some corners to get the prototype up and running. For instance, the metal rods have quite a bit of sway and nothing is securely attached because I didn't have my brass heat inserts when building the first prototype. So I plan to redo the entire dispenser to make it more robust, more polished and less prototype-like. And that's what I will do in the next video. I will try to complete the dispenser, make it more finished, add a bunch of features and just improve it overall. And then I can move on to the conveyor belt. If you have any suggestions on improvements or other stuff, just comment down below, and thank you for watching.